Today I have not one but two cameras to take a look at. I specifically picked up these two broken cameras because they both use Fuji's SuperCCD technology. Most sensors at the time were CCD based, and they were all basically the same. They all use a Bayer pattern filter on them, the red, green, and blue pixels, in a specific arrangement where you get more green than red and blue because our eyes are more sensitive to green. The SuperCCD was a design of Fujifilm, which is why these are both Fuji cameras, that kind of changed the arrangement of them. They kind of played with different layouts of the pixels. Instead of just laying them in a grid for the sensor elements, they would actually put them on a diagonal. There's ones where they have a large one and a small one. The idea being the large one is good for black and white, but low light. And the small ones are good at reading color, but not as light sensitive, similar to how the rods and cones in your eye work. And they tried different arrangements over the years. Now they're big into the X-Trans sensor, which is basically just a modified version of a Bayer filter. I think it has bigger green bunches. I've always seen images of these shown like in the marketing material, but I've never actually seen what the sensor looks like up close. Like I said, they kind of changed their designs over the years of the different generations. I believe this FinePix 4700 is the very first model that used it, so it's a first generation one. This is a professional FinePix S1 Pro, which is actually a Nikon film camera that's been rebranded and modified to have all the electronics put in it. So it actually takes standard Nikon f-mount lenses. Like many designs where it's a modified film camera, it actually has batteries for the electronics. It's all corroded in there. And separate batteries for the camera, because it's still a standalone camera. As you can see, this is very broken, as is this one. So yeah, that's why I got these. One, because they were super cheap, and two, because I knew I'd be ripping them apart. Looks like fairly straightforward optics for the lens, although obviously I'm missing a big chunk of the lens, so nothing fancy like image stabilization or anything like that in this. It's simply a basic zoom lens that's motor controlled. And the design of this is interesting. I mean, it's definitely different compared to today's cameras. It's not actually a bad design. Like, it's comfortable to hold, well made. It's a magnesium alloy body, and there's a mode dial and little LCD here, teeny tiny LCD. These both have really tiny LCDs by today's standards, and it just has a simple array of controls on it. Like many of their cameras, these use smart media cards, which a lot of people have probably never even seen. These are essentially just NAND flash wired in directly to this pin out, and yeah, there's no controller or anything. They just purely read off the memory chip, so the camera's responsible for any type of wear leveling. I don't even think they do proper wear leveling or anything like that. As a side note, if you're ever looking around and you find these, they're not really worth that much. They usually sell on eBay for a few bucks. Look for ones that have a notch on this side. If there's one with a notch on this side, it means it's a 5-volt card, as opposed to this one, which is a 3.3 volt card. The 5-volt cards are actually worth quite a bit more money because they're used in a lot of older sampling machines and synthesizers, stuff like that, like Roland, I think, use them in a lot of stuff. So they're actually worth quite a bit more. Like, they go for like 50 bucks for like just like a 4 megabyte version. Both of the cameras can accept those cards, except this one also has a CF card slot. Okay, so I've got most of this apart, but what I'm going to do now is I'm just going to check this flash capacitor and make sure it's drained, because I hate flash capacitors, especially when you think that it's drained and it's not. 0. Doesn't surprise me, it's been unplugged for weeks, but just because you've had no battery or power attached to it for a long time does not mean that the capacitor isn't charged. Many of them hold a charge for weeks, so it's always a good idea to check, because although it probably won't kill you or anything, you can often, especially if you're trying to repair something, you can often zap yourself and drop it and break what you're trying to repair. So it's just generally a good idea to make sure that you're not going to zap yourself with it. Let's see what we can do here. I'm really only interested in the sensor and the main board. Most cameras are built more or less the same way. They're generally main boards and a whole bunch of flex cables, although look at the number of circuit boards in here. There's like 3, 4, there's like 4 PCBs in this thing. Crazy. Compare that to today where it would just be one board. So let me try and take this apart a little bit more. Little connection for the speaker, which is picking up all of the screws. And it looks like there's just a large flex cable. They've got this either for shield, yeah, probably for shielding. I don't think it's for heat. It's just looks like it's a switch mode power supply. So they're probably getting some transfer into all the electronics here. Boy, even this display is huge. This dates back to around 2000, I believe. It's a good 20 years old by now. Small silicone connection for the backlight. No LEDs here, I don't think. This looks like a hybrid board with a flex cable running through it. So let me see if I can pull this apart a bit more. 330 volts with a 110 mic. So this board looks like it's pretty much all just power supply and the analog connection for the video out and the USB connection, which is a proprietary nonsense connector. And there's a high density connector that runs to here, which looks like it's more analog stuff. It might be the sensor readout. There's also a battery backup on this. Okay, a little piece of metal for the chassis. And yeah, this is all just a hybrid flex PCB, flex rigid PCB. So this looks like it's the connection down to the small LCD and controls here. And yeah, it's just a standard PCB with some membrane switches, or tactile switches. And this is the card reader, probably an IC on this side. It's soldered to it, but we can just break through that. Oh yeah. Looks like this is a custom IC with, looks like some bare die memory. And yeah, it's a fairly beefy looking CPU. I assume that's a CPU because this IC over here looks like an analog device, is probably a DSP. Yeah, I can't really read what that says exactly, but it's probably an ADC. It's even branded Fujifilm as well. So there's quite a bit of support chips. These are probably all dealing with the readout from the sensor. CCDs require somewhat complicated circuitry for the most part. Definitely embedded into the board. And it doesn't look like, oh, okay. I was gonna say it doesn't look like there's a lot of interconnects, but yeah, there's a lot in there. I was just looking at this side, which is probably just power and ground. And then there's all of those fine pitched ones. On the case, there's just a little metal slider for the lens cover when it's not in use, and just a couple light pipes and stuff. There's not really much in the chassis here. Pattern here to detect exactly where the focus or the zoom is. I assume this is for the zoom. This is a much larger motor, and it looked like there were some linear motors of some type in there to handle the focusing. So there's a fairly complex gearing system, 2 motors in here. So I'm trying to get that sensor out, which is going to be the screws right here. Yeah, it's just held in with a little bracket, and it's actually mounted on a flex cable, and then they just have all the connections going off to the readout and the motors. Fairly big IC, multiple layers of ceramic, and then you've got it topped off with an IR cut filter that'll block infrared light. There, now it's an infrared modified camera. It's that simple. So yeah, that'll just be a small IR cut filter. And we have this, which is covered in glass, so that might be a little difficult to get an up-close shot of it, but we'll see what we can do when we get that under the microscope. Like I said, this is a modified film camera, so it's basically just one of their standard film cameras that's been attached to an electronic portion. This is a mechanical drive screw for lens focusing, which is a holdover of the Nikon F mount, which is an ancient mount that they've continued to use forever. They just recently came out with the Z mount. It has a completely electronic interface. The complexity of the F mount is a little daunting for some people because some cameras don't have the focusing motor, Some of them do. Some lenses require the focusing motor, some don't. So getting all that right can be awfully difficult and complicated. I don't know why I'm taking the mount off right now, but I saw screws and I just kind of automatically started unscrewing them while I was talking. Because this is a digital SLR, it has a mirror in it. I don't know why the mirror is up. That's very unusual that the mirror is just in an up position when it's powered off. Could be that the mechanism is broken in some way, or maybe just this particular camera has it down. Usually cameras don't have it. The shutter is also closed. There's a very thin shutter here, and behind that will be the sensor. When this mirror is down, there's a small mirror that pops out. You can see it there. So this center piece is a half mirror. It allows light to go through this piece of glass, bounce off here and down into the focusing sensor, and then up into the viewfinder, which you look through here, which is actually plastic. I was very surprised it's actually a plastic window. On the back, it's your standard assortment of controls for an older digital SLR. And yeah, this one is broken to hell. And there's also a little compartment for the battery backup. So it actually needs 3 separate types of battery. I have to hand it to Fuji. Over the years, they've experimented with a lot of different sensor technologies and trying to break the mold of standard sensors, which has its pros and cons. I mean, obviously the majority of the research and everything goes into the bare sensors, so they usually have an advantage, although Fuji will argue that their designs have advantages in other places. Software compatibility is a huge one. Like the raw files are capable of being read in pretty much anything when it's a standard bare sensor, so you definitely have trade-offs. The hell is that? Is this just a dummy battery? I think this is. I think this is just a pair of dummy batteries. Yep. Well, that's a new one. Yeah, these are just meant to take up space so you don't have to put in 2 sets of batteries. That is really weird. I've never seen that. I'm still looking for the flash capacitor in this one. This one has never been powered on since I've had it. I did power on the smaller camera at one point. No matter what, you're always missing a screw somewhere. They do like to hide them on you. Well, I think brute force is now called for. There we go. That works. Oh, wow. So they've seriously just kind of attached the sensor to the back of this film camera. That is funny, and you can see these read the DX codes that are on film canisters, on 35mm film. And this is the take-up reel, so it's all still here. Looks like the motor's even installed too. So yeah, they're really using just a standard film camera. I'm not going to take the film camera apart completely because I don't think they'll be very, there's no electronics in there really aside from metering and stuff like that. So I don't think there'll be any real need to take that apart. But this looks like it's just held in with some screws. Oh, wow. It's actually a very large sensor. I don't know what the crop factor is on this, but that is a pretty beefy looking sensor. And again, this is on a flat flex cable. And there we go. One much, much larger sensor. You wonder why big cameras have less noise? It's because look how much more light you can gather. So this one, it looks like the IR cut filter is integrated into it. So again, I'm not sure if I might have to break that off to get a good shot of the sensor, but we'll figure that out. Looks like the flash capacitor went with the top half of the case, so shouldn't have to worry about that. So this bottom section looks like it's essentially just another DC board, and it also is outputting the backlight power. And then this main board looks like it has all the same components as the little camera. They're probably faster versions of whatever chips they're using just to handle the increased data rate of a much larger sensor. This is all just the PCB for the membrane switches, the LCD, and then you have the black and white old school LCD that they like to put on cameras. Down here it's just memory card readers and the power supply components. Both cameras seem to share a lot of the components. They still have this big Fujifilm IC and the PXGA from Analog Devices, which I can't really find any information on. Looks like it's some kind of gate array, but I don't know. Could be an ADC with just a weird name. And you have your standard support stuff. You have some flash memory for the firmware, and then you have a big chunk of memory for buffering, power supply stuff driving the CCD, I'm sure. And a Sony chip that's most likely just a CCD driver of some type. And yeah, that's about it. There's a buzzer. All right, under the scope, first is the large sensor from the FinePix S1 Pro. This one, I did confirm it is an APS-C type sensor, so it's approximately 1.5 times crop. It suffered a little bit of damage. I took the IR filter off both sensors by heating them up. When this one heated up, it actually shattered the glass, which damaged the sensor just a little bit, but there's plenty of sensor to go around, so shouldn't be a problem taking a look at it. Along the side, there's tons of test points, and I did find some text along the bottom here. There we go. Fujifilm Micro Devices. Now this is a 3.4 megapixel sensor, only 3.1 effective megapixels, because some of them, you can see that little line there, some of them aren't used for image taking, they're used for calibration and other things. So basically a 3.1 megapixel sensor. Because of the diagonal pixels, the image can be interpolated in a way that it shows up, it basically produces a 6 megapixel image, which initially on the 4700 they marketed saying, oh look, it's got double the megapixels, but in reality the number of pixels is half that, so they were lying. They changed the marketing just before it came out, at least on some cameras, but I remember there being some controversy over it even after they were released, so I think something got released with the fake branding, so to speak. So this is just at 4x magnification. If we move in a bit to 10, pattern is becoming a lot more clear. We can see that it is a weird kind of diagonal grid of pixels. You can see that the underlying layer is blue. Each mask has its own layer, and I think the way they do it is each color pixel is on a different layer and they code it differently. I'm gonna try and get my hands on a camera with a sensor that uses the large, small type SuperCCD. I still have to do a little bit of research and figure out which particular models have that. Then I gotta find one that's broken so that I'm not killing a perfectly good camera, even though they're all so old that no one really should be using them. I now have these much smaller image sensor from the 4700 under the scope, and this one is the MS3851, again by Fujifilm Micro Devices. This one is only 2 megapixels, and moving along, it looks like there's a little bit of a test pattern there. Yeah, I'm gonna say that they actually do the colors on different heights, because you can tell by the red, green, and blue here that they're more or less out of focus as opposed to the green one, which I have in focus right now. If I move the focus, it looks like they're going in and out at different rates. So I think the blue is on a lower layer, and there's little test patterns, probably checking the resolution of the mask. And then same thing here, there's also the blue layer, and then we have the pattern, which looks like it's exactly the same. Well, the pitch on this one is a lot finer. They're definitely using a much higher density sensor, which is fairly common with the smaller sensors. The much larger APS-C sensor has 3 megapixels. This has 2/3 that in a much smaller sensor. Unfortunately, my 40x objective isn't particularly high quality. It came with my scope. I do have a brand new 100x Zeiss one, an old school Zeiss optic, so I'm gonna try that in a sec. When you get to 100x, it becomes a lot more complicated. You have to put oil on the object in order to maintain the refractive index. You have to put oil on it and, you know, wipe it off. You know, now that it's up this close, you can really see that for every square there's a red one, a blue one, and 2 green. So they are just using a diagonal Bayer filter. Well, I don't think there's really anything else to learn from this. I thought it was just interesting. I've always wanted to see what these sensors were like up close. I hope you at least learned something.